Okay, so in this video, we're going to look at a few more features that we're going to mess around with in Energy 3D. The first one that we're going to mess around with is looking at how we can change some of the values for a specific house. So I'm going to go up to my examples menu and I'm going to do simple buildings, and I am going to pitch Dutch colonial this time. And I'll still find it easier to just orient my house to where I'm looking at the south side of the house. You know, that's my personal preference. You guys can pick whatever angle that you guys would like. And as we saw last time, that when I click on an object, it's going to tell me information in the right about that particular object. So in this case, I've clicked the roof, and you can see where it's highlighted um, on my selection point. And you can always edit things as needed by getting rid of the points, and you can change your roof as needed. So now I have a really funky looking roof. um, and so that gives me my R value, the area, and it's also letting you know about the general availability of sunlight and energy that you could absorb via solar panels. So 0.8 is pretty good. Right? And it tells us how much sunshine we get per day on this particular day in Boston, Massachusetts. So you can change all of these variables, and eventually we will. Okay. So I'm going to do a quick look at my cost. Notice most of my cost is in the walls and the foundation for the house, which is probably good because that helps the house stay up. But like all the other components, that if I click on the wall, it's also going to tell me the same information. Now, if I right click, I get a menu that pops up. And so on a Mac, you can control click, and that's just equivalent to a right click on a PC. I can change the thickness, I can change the height, I can change the insulation, and I can even change how much heat that it holds as a whole volume. So that's all the wall together. Generally won't play around with this as much. But notice you can decide on if you want your house made out of stone versus brick versus concrete. Right? Stone is actually quite good in terms of retaining heat. So right now we've got it set at 0.5. We'll just leave it at that. But the one that we want to explore here a little bit is our insulation value. So a U value is similar to that volumetric unit. Notice it's watts per meter squared per degree Celsius. So what that unit is telling us is how much energy is moving through a square meter. Okay? And that by Celsius is the how much temperature difference is across that square meter. Okay? R value is a measure of conductivity flow of heat. The higher the value is, that reduces the amount of heat that's flowing. And it's in these weird units. Basically, it's how much BTUs flow across per inch or per foot, depending on what unit you're using. And here they're using feet, um, basically per second. So I'm going to change my R value here to 40. Okay? And notice it automatically updates the U value, so you can change either one because they're not separate variables, basically. Again, the mu is everything. R value is the specific insulation value. Okay, so I'm going to show that. And what you want to pay attention to as you change it, you're going to notice that the cost of my walls are now a lot more. Because anytime you're adding insulation, I'm going to change this to 100, which is really, really high insulation. Not even sure you can buy R value of 100 in terms of insulation. All right, so now my walls have gone up to $76,000. And notice the walls are now approaching almost half the cost of the entire house. So let's put this insulation value back down to something reasonable. Usually 20 to 30 is pretty good. All right, and so, oops, move it over. So I'm now say $5,000 right on my walls. Okay, same thing with the roof. You can do exactly the same thing. Same thing with your windows. So when I right click on it, is you can change these variables that you put on. So sometimes when you buy windows and you go shopping for windows, you'll hear about different glazes that they can put on, different tints they can put on. You can buy single pane glass, which are on the old buildings at BC because they're stained glass, so you don't want to ruin those. Though you also will see where they've got stained glass and then glass surrounding them to preserve the glass and also to create better energy conditions. And so that saves you money. And you can also go all the way up to a triple pane glass, which is glass, air, glass, air, glass, because stagnant air is actually very good at absorbing heat. Okay. Now, the other thing that we're going to want to do is we can go in and again, you can plant your trees, you can you do different objects, you can put different doors around, you can put a number of different windows around, and all of that is going to impact your total cost for your house. Okay. And then you can also go over to your analysis and I'm sorry, your view, and there's a menu option down about halfway down where you could say solar irradiance heat map. This is going to show you the best places to put a solar panels for your house. So notice with my nice editing of my roof, this side of the house just isn't very good to put solar panels, so it's a waste of money to put them there. Not surprising, this is the north side of the house, right? But if we move this house to South America, it would be exactly the opposite. Right, again, because it depends on where the sun is in the sky. And if you're ever curious, you can click on the little path icon where it'll show you where the sun is at the particular time of day. And you can also simulate by having it animate where the sun is moving if you're not quite sure where you are.